Now we're going to discuss a very common idea that is called central tendency. Central tendency are of two types. Center means obviously a position. Central tendency measurement will be measured with two ideas. One is first order central tendency, first order, and the second order. What is first order? First order means to locate location of the center of the data, because in statistics you will find a lot of data are there, and dispersion is the second. Dispersion means scatteredness, how much variation is found in the data. That means if you consider one batsman like Virat Kohli, what is the center run, what run he is scoring, center of his career, that is a location. Now if I want to measure the variation in his runs, then that will be dispersion. This is a separate thing. First chapter is normally known as central tendency, second chapter is normally known as dispersion, but actually both are can be clubbed in one topic, that is central tendency. Now location means center. Now center will be of three types. First type is average, which is mean. Average we consider as mean. Secondly, it is median. Median means middle value, middle position. The data which are given, which is the middle position value. And mode is most frequent value. Mode or modal value also we say. Modal value. This is the most occurring value. Most occurring value means which value is is observed most frequency. The having most frequency, number of times if you watch, which value has occurred maximum number of times. Now middle value will be positional average. It is also average, but it is positional. Why positional? Because it is at the middle. That is why it is positional. But average, this average is a different type. I'm coming to this discussion. First is mode. Mode you know, like fine mode. Fine mode. It's very easy thing. Mode is like of 2, 5, 8, 8, 9, 10. Obviously, which value has occurred maximum number of times? You'll be telling 8. So your answer will be mode is 8. Yes, true. It's not very difficult. A very simple thing. But I tell you one thing. There is a problem. What problem? Problem is, if I include one more 9, then what will be the case? That is the problem. This concept, another 9 is included. If it is there, then we cannot say 8 is the mode. This is bimodal, means two modes. Yes, there may be two modes or three modes. In this case it will be two modes, that is 8, 9. Both are to be answered. This is called bimodal. But if I say it is the case, this is the case. I have changed the question. I am changing the question. This is the question. The question is like this. Find the mode. So what is the mode? 2, 5, 8, 10, 9. No mode. Undefined mode. So mode has a very important point to watch, to remember, that mode may be undefined. Mode may be more than one answer or more than one result. That is called bimodal, trimodal, multimodal generally, more than one mode. And mode may be uniquely also found. Unique means only one answer. Now coming to the second discussion. I have started with mode because it's easiest method, easiest measurement. Now come to the next measurement, which is median. Median is very easy because median means middle value. All you need n plus 1 by 2th ascending value I am saying. It's not that you need to arrange in ascending order. You may arrange in descending order also. But I tell you, ascending values are better than descending, because ascending values are more used in more measurements. There will be various measurements in statistical analysis. I prefer you should learn with ascending concept. And n plus 1 means number of data plus 1 by 2th position. There is a question. In lower classes we have seen even data, odd data. That is not very important now. Like I am giving you an example. Find median of 3, 8, 10, 12, 6, then 9, then 10 again. Now what to do? First you arrange in ascending order. What is the ascending order? Ascending data will be this way. Lowest one 3, then 6, then 8, then 9, then 10, again 10, 12. Both 10 should be included. Now you see how many data? 7. So n is 7. You have a very simple answer. 7 plus 1 by 2th position. That is 4th ascending data. 4th value of this series, not the given series. Don't take the given series because it is not given as an ascending one. But now we have ascending data. So the 4th value, first value, second value, third value, 4th value. So your answer is 9. This is the idea how to find out median with the help of given data. This is a discrete or raw data or simple data. Later I will discuss the idea of frequency or given data in distribution form. Now coming to, if I ask you this way, find median of 12, 18, 32, 18 again, 10, अच्छा 18 नहीं, not 18, 10, 15, 8, this way. Now first thing we'll do, arrange the data in ascending order. So ascending data is, which is the ascending data? Ascending data means it will start from 8. 8 is lower value, then 10, then 12, then 15, then 18, and lastly 32. So you have 6 data. You have 6 data. That is the very important point. 6 data. So n plus 1 by 2. That is 6 plus 1 by 2, which is 3.5th value. Very awkward. 3.5th value is no, it is not making any sense. So what we'll do, third value plus fourth value by 2. So why third value and fourth value? Because 3.5 is in between third and fourth. This is not very important to write. You just think when you see the data, actually ascending data you are seeing, obviously you are having 2 medians. No, we cannot have 2 medians. Mode may be more than 1. Mode we can have bimodal, 2 modes. But in case of median, we cannot have 2 median. Median will be always 1. And that only 1 median means n plus 1 by 2th value is 3.5th value. 3.5th value makes no sense. Third value is 12 and fourth value is 15. So what we will do? Third value is 12 and fourth value is 15. Add these two divided by 2. Don't write 3.5 is median. 3.5 is the rank of the median. That is the position of the median. And your answer is third plus fourth value by 2, which is obviously 13.5 is median. This is the median. That's all for median. So mean, median, mode. I have discussed median and mode. Now the last one, that is mean. In this case, we have 3 types of mean. This is very important. Average. I will discuss in detail in this topic. But today I am just discussing the basic thing. 3 measurements. One is arithmetic mean. Arithmetic mean is adding. Next is geometric mean. This is multiplication, product. And next one is harmonic. Harmonic mean is reciprocal. 3 things. Arithmetic mean, we write am or x bar. X means the values. X are the values given in the statistical data we are recording in figures, and that are denoted by x, and that x bar is mean of x or arithmetic mean of x. Geometric mean will be denoted gm or simple g, and harmonic mean is hm, which is also h, which means x bar, very simple, total of all x, summation x means all values of x are added and divided by the number of data. Today I am doing the basic thing of mean, average. Add all the values divided by number of data. Geometrical mean or geometrical mean is geometric mean, gm, will be multiply all the values to the power 1 by n. And harmonic mean is n, that is the number of data, divided by total of reciprocal values. So 3 formulas, am, gm and hm. Am is average or simple average, which we know from our arithmetical concept, adding the data and divided by number of values. and geometric mean indicates multiply all the data to the power 1 by n, and harmonic mean is nothing but reciprocal of the values divided n by all the reciprocal data to be added. Now come to the examples. I am taking an example, all the three I will show. Find AM, GM, HM. All the three I am showing. Find AM, GM and HM. Means I want to show all the three in this example. 1, 4 and suppose 16. Yeah, or it will be I am doing better. Okay, let it be. Now come to first measurement, AM. AM is 1 plus 4 plus 16 divided by 3. Why? Because there are three figures, 1, 4, 16. So n means number of data. What is n? N means number of data. So how many data are there? 3 data. So you add summation x means total 1, 4 plus 16 and it comes to total is 21 by 3 which is 7. So what is the result? 7 is arithmetic mean of 3 figures. Now geometric mean. In geometric mean we have some little difficulty. You will multiply all the figures 1, 4, 16 to the power 1/3. Why 1/3? Because there are 3 figures. 1 into 4 into 16. That means you first multiply all the figures. Here we have added all the figures. Here we will multiply all the figures. It is 64 to the power 1/3. When I was discussing indices little bit, I told you that we will need this topic indices in some chapters. Yes, in geometric mean we need to know how to calculate GM with the help of that idea. We can have our calculator, but in normal calculator power is 1/3. Cube root, it's a bit difficult. So you do one thing, you write 64 such a way that this will be in power. You will be saying I will write in 2 to the power. And 2 to the power 6 your answer. If you write 2 into 2 into 2 6 times, so it will be 2 to the power 6 1/3. Now some students say no, I'll write 8 square. Bad. Why 8 square? I need 1/3. 8 square will be difficult. It is not easy. Because one student asked me, how you know that it will be written 2 to the power 6? Yes, I have another option. I can do that. Any number to the power like this. 4 to the power 3 is also 64. Yes, that can be also done. Either you write 2 to the power 6 to the power 1/3, 2 to the power 6 means 64 to the power 1/3, or you write 4 to the power 3 to the power 1/3. To the power 1/3 because 3 values. Had it be 4 values, it will be 1/4. If there are 2 values, it will be half. 2 values, then it will be half. So what you are seeing? The answer is 4 because this and this cancelled. But here it is 2 square which is also 4. So look at the answer. In both case your answer is 4. Which method you are applying is not very important. Here what I have done 4 to the power 3 then whole to the power 1/3. 3 cancelled out, you get the result as 4. But here what I have done 2 to the power 6 to the power 1/3 2 square and answer is also 4. So your answer will be same. Your choice. Just do. Statistics rely on mathematics, but doesn't mean that you need a lot of ideas of mathematics, basic ideas. Now harmonic mean. Harmonic mean number of data, that 3 data divided by all the figures will be reciprocal. That means 1 by 1. 1 by x means reciprocal. Then 1 by 4 and then 1 by 6. You can 1 by 16, sorry, 1 by 16. Now you can solve with your calculator. 1 by 1 is 1. 1 by 4 is 0.125, 1 by 16 is 0.06 something, and you can do that way. But if I apply mathematics here, little bit arithmetical idea, that means we can simplify. Arithmetical idea means what I do 1 by this 3 divided by 1 plus 1 by 4. I wrote this one. This is the harmonic means calculation. So it will be LCM is 16. Taking the LCM. It's a long method. This is 4 and that is 1, 3. This 16 will go in the numerator. Because the rule is mathematical sense, the numerator and the denominator. This numerator divided by a fraction, then that fraction's denominator will be in the numerator. That is just opposite. Because it is divided. You know, 3 by this, but obviously this will be divided. And this is 16 by 7. So your answer is approximately 2.5 or 2 or like that. So you have got AM is 7, GM is 4 and HM we have found. So this is the concept of AM, GM and HM. Now I would like to discuss one last thing, that for two values what will be the result. For two values, only two values. Remember, very important. For two values, only two values are given. Two values means any two values. Remember, AM into HM will be GM square. Very important result. For two values, if you find the arithmetic mean of two values and geometric mean of two values and HM harmonic mean, then there will be a result. We have to remember this result. Like I am telling, 2 and 8. Find the AM, GM and HM. And I will show the result. AM will be 2 plus 8 by 2 because two values are there, 5. GM will be 2 into 8 to the power 1 by 2 because two values, we can do this 16 to the power half, or we can take the square root because to the power half is square root. We can say 4. So GM is 4. And what about HM? HM is 2 divided by 1 by 2 plus 1 by 8. That means 2 divided by, LCM is 8, 4 plus 1. So it is becoming 16 divided by 5. Now come to what I said. It's not important to show, but I am wanting to show that what I said before, for two values, AM into HM will be GM square. To verify that, to establish that, I am just doing that here. You remember the rule, but to establish that, I am showing this. AM into HM, you just multiply 5 into 16 by 5. 5 into 16 by 5, 5 cancelled, 16. And what about GM square? GM square means 4 square. What is 4 square? 16. So what you are observing? AM into HM for two values will be always GM square. Always. Irrespective of which are the values. Two values will be there. Like 2 and 8 in this case. It can be anything. So AM and GM, if you multiply, AM and HM, sorry, your result will be always GM square. So they can do one thing. They are giving AM and they are giving HM. And they are asking what is the GM. So you multiply AM and HM, your answer will be taken square root and your result will be the GM value of the two data. That type of concepts we can ask. This is all about this statistical central tendency initial concept.